Good morning, Trig. Welcome to first block and third block Trig class today for Friday, February 3rd. What we're going to do today is we're going to look at the unit circle that we began, what day? Wednesday. Well, we began it Wednesday. Yes, we began the unit circle Wednesday, and we put all of the degrees on that unit circle, and your assignment was to take that unit circle and convert those degrees into radians. So you should have that unit circle out in front of you, okay, along with an extra sheet of notebook paper and a pencil. And what we are going to do is we are going to make sure that the radians that you have on your unit circle are correct. After that, we will then go into a PowerPoint that will fill in the last blank on your unit circle, and you will leave here today with a complete unit circle that you will then take home this weekend and memorize. Because on Monday, I'm going to give you a blank one, only it's going to say quiz at the top, and you're going to have about 10 minutes to fill it out. Okay? So you will leave class today with a complete unit circle. You will memorize it this weekend, okay? And quiz on Monday. All right. We know that this is, I'm going to real quick put the degrees on here, 0, 30, 45, 60, 90. Starting in the second quadrant, what's this first one that we run into? 120, then 135, 150, 180. Down in the third quadrant, 210, 225, 240, 270, 300, 315, 330, and 360. Okay? So that's all repeat. I went very fast on that because everyone should have that down on their unit circle. Okay? For the radians, 0 degrees is the same as 0 radians, so we don't have to write 0 down again. So at 30 degrees, what is that in radians? Pi over 6. Very good. And what about 45?
Pi over 4.
Pi over 4. What about 60?
Pi over 3.
Good. And at the top?
Pi over 2.
Pi over 2. All right, these should be going or should have gone in the second blank, right, on each of these little stacks of blanks. 120 would be
2 pi over 3.
2 pi over 3. For those of you in third block, that is Ross trying to be as loud as he possibly can to be heard by the microphone. 135 is
3 pi over 4.
3 pi over 4. 150,
5
5 pi over 6. 180 is pi. 210, 7 pi over 6. What's 225?
5 pi over 4.
5 pi over 4. 240,
4 pi over 3.
4 pi over 3. 270 is
5 over 2.
3 pi over 2. 300 is
5 over 3.
5 pi over 3. 315 is
5 over 4.
7 pi over 4. And 330 is
5 over 6.
11. Oops. Hold on, I got a little glitch on my board there. I don't know if you guys can see that. 11 pi over 6. And then in my third blank up here, it's 2 pi. All right? If those are not the values that you have on your unit circle, you should be erasing and changing them to what we have up here. Okay? The question that I got on Wednesday was, well, what goes in the third blank? And the answer is, since we're on a coordinate plane, what goes there are ordered pairs. Okay? Who can remember why we call this the unit circle? I mentioned it on Wednesday. Why is this called the unit circle? No? It's because the radius of this circle is 1 unit. We don't know what the unit is. The unit is irrelevant, basically. But the radius is 1. Okay? Now, where did these angles come from on this unit circle? Where did I tell you that they came from? Something from geometry. Where did all these angles? The 30, the 45, the 60. Those special right triangles from geometry, the 30, 60, 90, and the 45, 45, 90. My guess is that if the unit circle involves the special right triangles, we might need to review real quick those formulas. Okay? in a 45, 45, 90 triangle, better known as an isosceles right triangle, okay, you know that the legs have to be the same because the angles are the same, okay? Does anybody remember what the relationship is, bless you, between the leg and the hypotenuse? Okay, well, Pythagorean, yes, will work. However, typically on a special right triangle, we only have one of the sides instead of two.
2s.
Nope. Hypotenuse equals the leg times the square root of 2.
No.
Okay? So if I tell you that the leg is 7, then the hypotenuse would be, if the leg is 7, the hypotenuse would be 7 times the square root of 2. Okay? Do you guys remember that vaguely? Yes. Okay. If I gave you one where I told you what the hypotenuse was, let's say I tell you that the hypotenuse is 6, how would you work backwards to find the leg? Right, 6 equals leg root 2. You'd have to actually divide by the square root of 2. Ooh, this is interesting. 6 divided by the square root of 2. Is that an okay answer? No, what do you have to do when there's a square root on the bottom? You have to rationalize, correct? Remember doing that? Okay. Rationalize is that big fancy word that means get the square root off the bottom. 6 times root 2 is just 6 root 2. The square root of 2 times the square root of 2 is plain 2. And then the 6 and the 2 will cancel. Okay? So that's really 3 root 2. All right, you may have to rationalize a little bit today. All right, so that's a good skill to review. So that's the formula for a 45, 45, 90. Okay? 30, 60, 90s. Those are not isosceles because the angles are different. One of the legs is shorter than the other. So in my class, when I teach geometry, I call this one the short leg. I call this one the longer leg. And the hypotenuse.
2s.
Okay. Ross, what's 2s?
2 times the short side.
2 times the short side, but what is that?
Hypotenuse.
Okay, good. One of the formulas that you have is hypotenuse equals 2 times that short side or short leg. Okay? To get the longer leg, you have to take the short leg, and does anybody remember what you have to multiply that by? It is. It's the square root of 3. Very good. Okay? All right. By the way, for third block, if at any time we are going too fast, when you look at the screen, since it's a movie file, you should have the ability to pause it, and you can pause, catch up, and then continue playing. All right. With those two formulas, I'm just going to give you one quick example just to kind of see how it works. All right. It's easiest if the short leg is given. So let's say I tell you that the short leg is 5. What would the hypotenuse be? Hypotenuse would be 2 times 5, which is 10. And the long leg would be 5 root 3. Okay? Of course, if I gave you the hypotenuse, let's say the hypotenuse is 12. The short leg would be 6, and the long leg would be, 6 root 3. That does look cool. There's a glitch in my board right there on that spot. Okay? That's just a quick review of the 30, 60, 90, and 45, 45, 90 triangles that you know about. And we need that because when we talk about the unit circle, you have to know those in order to determine those unit circles. Remember, or not the unit circles, sorry, the coordinate coordinates for the point. Whew. All right. Here we go. We're going to add coordinates to the unit circle. All right. Why is it called the unit circle? Tell me one more time. The radius is 1 unit. So you can see the coordinate plane. You can see our unit circle. Life is good. We're going to start on the axes. Over here on the right, you can see that it's 0 and 2 pi. We already have that marked on our unit circle, correct? Okay, and 360. That's correct. We're thinking radians, though, pretty much today. All right. So over here, if I start at the origin and I move to the right 1 unit, this point that shows up right here on the edge of my circle, that's to the right 1 unit, which corresponds to the ordered pair 1, 0. Everybody got that written? Okay. All right. Up at pi over 2. Dalton says it would be 0, 1. Do you agree? Okay. Let's see. 0, 1. And now we move over to the left on the negative x-axis. At pi, it should be negative 1, 0, because you're moving to the left. And then if we go straight down at 3 pi over 2, that would be 0, negative 1. That is amazing. All right, so the question is, how do we get the rest of the ordered pairs? And the answer to that is, we have to think about those rules that we just went over with the 45, 45, 90s and the 30, 60, 90s. We have to keep those kind of in the back of our brain, because if we take a look at this 30-degree angle, right? This is our central angle right here. So this is at pi over 6, right? Because that's my 30-degree angle. The 90 degrees, if I drop this altitude straight down, that forms a 90-degree angle with the x-axis, which forces that angle up here on the right-hand side to be 60 degrees. It's a 30, 60, 90. It's a special right triangle. Now I want you to look at that triangle, and I want you to tell me if you know what any of the side lengths are. Do you know the short leg? Do you know the long leg? Do you know the hypotenuse? Do you know any of them? Oh, Giovanni says that the hypotenuse is 1, and he is correct. Why is the hypotenuse 1? That is correct. It's the radius, right? Okay, so if we take a look, okay, I'm stuck. There we go. The radius is 1 for the unit circle. That means that the hypotenuse is 1 for this triangle. Now, here are our formulas showing up. Hypotenuse equals short leg times 2. So we substitute in the 1. 1 equals short leg times 2. So then the short leg must be 1/2. Okay? So that means that the long leg would be the short leg. We just found it. 1/2 times root 3. So that would just be root 3 over 2, right? Okay. Well, here's why. Because if you look at the triangle right here, here's the short leg, 1/2. This side at the bottom that's on the x-axis, that's my long leg, it's root 3 over 2. How would I determine the ordered pair right here? Don't I have to know how far to the right I've gone and how far up I've gone? And when I know that, then at pi over 6, the value for that ordered pair would be the square root of 3 over 2, comma, 1/2. Does that make sense? Because you're moving to the right, so it's positive root 3 over 2. You're moving up, so it's positive 1/2. And that is the ordered pair at pi over 6. Okay? Now, here's what's going to happen. We're going to stick with all of the pi over 6's because something really cool happens with the unit circle. A lot of you were asking the other day, are there patterns to this? There are so many patterns to the unit circle. It is just a matter of which ones, pop out to you. If I take this triangle and I reflect it over, just flip it over into the second quadrant, what happens is I land at 5 pi over 6. So it's got the same denominator, right? Okay, so the lengths are going to be the same except what? Okay, since I have to go to the left, instead of a root 3 over 2, it's going to be negative root 3 over 2. Am I still going up? Yeah, I'm still going up, so it's still positive 1/2. So the ordered pair is negative root 3 over 2, comma, 1/2. Does that make sense? Now we're going to take the same idea and we're going to flip it, only now we're going to flip it down. Okay? So there it is. Just flies right in there. What do you think that, first of all, what angle am I at? What angle am I at? Right down here. We're still at a pi over 6. It's 7 pi over 6 because that's the angle that's down in the third quadrant. That ordered pair would be, good, negative root 3 over 2, comma, negative 1/2. Does that make sense? All right. And then finally in the fourth quadrant, there's our last one. I'm going to move this down because I think it's in the way. There's my 11 pi over 6. So what should it be? Tell me before I show it. Good. Positive root 3 over 2, negative 1/2, and whoops, there it is. Okay? So right now, on your unit circles, everything is filled out for your axes, right? The x and y axes. And all of the pi over 6s are filled up, right? Okay. So now what we're going to do is we're going to take that same triangle, only we're going to flip it at the origin, which means that instead of the long leg being on the x-axis, now we're going to have the short leg. Okay? Instead of the long leg being here, now it's the short leg. What was the size of the short leg? It was 1/2. And what's the long leg? It's the square root of 3 over 2. So this ordered pair, first of all, we know we are at pi over 3. Okay? So then it's going to be to the right 1/2 and up root 3 over 2. So my ordered pair is 1/2, comma, root 3 over 2. Does that make sense? I didn't have to redo all that formula stuff with the special right triangles because it's the same triangle. It's just that it's sitting on a different vertex down there at the origin. Okay? Now we're going to do the same thing. We're going to flip it around. Guys, when you flip this through the quadrants, what's the only thing that changes? The negatives and positives, right? The signs on those numbers. So in the second quadrant, you should be at 2 pi over 3. And it's going to be negative 1/2, comma, root 3 over 2. All right? Once you get the hang of this, it's like money in the bank. You can count on it. You know what it's going to be. All you have to do is mess with your signs. Okay? Let's take a look at the next one. Third quadrant, what's that angle? Okay, the angle is 4 pi over 3. And then that ordered pair, let me move this little guy down. It's going to be negative 1/2, comma, negative root 3 over 2. All right? And then in the fourth quadrant, what's that angle? 5 pi over 3. And then 1/2, comma, negative root 3 over 2 because you're going to the right and down. Okay? Piece of cake? Maybe? Once we get the ordered pair down, we just have to remember which ordered pair goes with which angle. And I know that seems like a huge task when you look at this big unit circle with all of these pieces, but it's not too bad. All right, so let's do the 45s. Those are last, the pi over 4s. Okay, so now we have to redo all of our formula work because now we have an isosceles right triangle in here. All right. The only formula, like we discussed before for 45, 45, 90, excuse me, is that hypotenuse equals leg times root 2. And we know the hypotenuse. That's correct. We know the hypotenuse. The hypotenuse is 1, right? So if I do all this work, 1 equals the leg times root 2. Then I divide through by root 2. Oh, and then we get that rationalizing thing going on like we had before, remember? Okay? So the root 2's are going to cancel out here. And then I've got to rationalize right here in this step. And then I end up with, let me move my box again. I end up with my leg being the square root of 2 over 2. Now, that's the only formula I have. Why? The legs are the same. So when you look at this triangle after you do all that work, the hypotenuse is 1. Each of the legs are the square root of 2 over 2 because it's an isosceles right triangle. Does that make sense? Yeah? So what would the ordered, this is pi over 4 now, what would the ordered pair be? It'd be root 2 over 2 comma root 2 over 2. Okay? The x and the y values are the same. So if we do the same thing, we start taking this triangle and we start reflecting it around, what's going to be the angle over in the second quadrant? Okay, the angle's 3 pi over 4, and the ordered pair would be negative root 2 over 2 and positive root 2 over 2 because you're going to the left and then you're going up. Okay? Third quadrant, what's the angle? 5 pi over 4. And so that's going to be to the left and down, so it's negative root 2 over 2 comma negative root 2 over 2. And then the fourth quadrant, our very last piece of the unit circle, some of you are probably working ahead of me and are already done, but that's going to be at 7 pi over 4, and that ordered pair, since you're going to the right and down, is going to be positive root 2 over 2 comma negative root 2 over 2. All right? Take a look at your unit circle, make sure you've got everything filled in. And it should look something like that. Okay? Okay, so what do we do now? We've got our unit circle with our coordinates, which is super duper, and you're going to take it home and you're going to study it and memorize it because what's going to happen on Monday?
Quiz.
You're going to have a quiz. That is correct. In fact, it looks exactly like the blank one that you started with on Wednesday, except right there by the word trig, it's just got a big word quiz. That's it. It's the same thing. All right? It's memorization, and the sooner you memorize it, the better off you're going to be. Yes, sir?
On the quiz, are we going to have to write in like the 30, 60, 90 triangle, and 45, 45, 90?
No. On the quiz, the question is, are we going to have to write in the triangles? The only thing that you were going to do on Monday, in fact, I have one that I can hold up for first block, third block. You're not going to get anything out of this. But here's your quiz right there. It literally is a blank form of what you're holding in your hand, except there's the word quiz. The word quiz. It's memorization, guys. I make no secrets about the fact that you have to work hard to memorize things in here. If you do not know this unit circle by Monday, the rest of this class is going to be painful. Painful. I cannot stress that enough. Okay? When I tell you that you need to memorize, I am not trying to scare you. I am not over-exaggerating. You have got to know this unit circle like you know your own name. And for some of us, better than we know our own name. All right? Okay. So what we're going to do is we're going to go back to those trig definitions that you learned about in geometry many, many moons ago. And we're going to see what you remember. So we're back on our notebook paper. You should have had a piece of notebook paper out. We're back on it. What are the 3 trig words that you remember from geometry?
Cosine, tangent, sine.
Okay, sine, cosine, and tangent. So just in case we aren't familiar with those words, sine is really spelled S-I-N-E. What we do is we abbreviate it by dropping that last letter. Don't ask me why. And it looks like sin. It is a sin to say sin because it's really sine. Sine. What always goes behind a trig word is an angle. And what's our favorite letter for an angle?
Theta.
Theta. So sine theta equals. When you were in geometry, you had, it was basically just right triangle trig. You had this definition and it went with SOHCAHTOA. So sine was what over what? Do you remember SOHCAHTOA? Good. Opposite. It was the opposite side over the hypotenuse. Okay. If we think back to our unit circle, all right, so let me just flip over real quick. If I think back to my unit circle, and I have those triangles, and this is my angle theta, what's the opposite side? It was my vertical piece, right? This is my opposite side, so that's my vertical piece. Which part of my ordered pair was responsible for that vertical distance? Was it the x or was it the y? If I'm going up and down, that must be the y. Okay? So opposite over hypotenuse. Well, my hypotenuse in this case is really the what of my circle? It's really the radius. So what we're going to do is we're going to take our definition and we're going to modify it. Okay? So instead of us talking about opposite over hypotenuse, we're going to call it y over r. All right? And then our next trig word is cosine. All right, so I'm writing it out in full, but we abbreviate it as COS, cosine. Always behind a trig word you will place an angle, so we're going to put a theta there. In geometry, do you remember what cosine is? Good. Adjacent over hypotenuse. All right, but the side that was adjacent, it wasn't the y, and it wasn't the hypotenuse. What was it? Do I need to flip back? Good. It was the x. Let's take a look at it. So here's my triangle. The green y was the opposite side, but this right here, that's my x. That's my adjacent side. So if it's adjacent over hypotenuse, then it's x over r. So we're going to change r's for our trig definition to be x over r. And then the third trig word that you learned about in geometry was tangent. Very good. Does anybody remember what tangent is? I heard it. Opposite over adjacent. Very good. Okay, but on that little triangle, the opposite was really what? Was it x or y? Opposite was y, and adjacent was x. So we're going to be looking at the y over the x. Okay? Now, here's what we didn't tell you in geometry. There are 3 more trig words. And they are what we call the reciprocal trig words, or the reciprocal functions. Okay? Now, if you, depending on if you had geometry at Simonson or JC, and depending on who your teacher was at Simonson or JC, you may have heard about these. So I'm assuming that nobody has. So if you have, fantastic. It's just a review. The reciprocal for sine. Okay, so first of all, what's a reciprocal? What do you do?
Opposite.
No, no, no. We don't say opposite in math class. You flip it, right? You flip it. Okay? So the reciprocal of sine is what we call cosecant. All right, that's the full word spelled out. The abbreviation is CSC. Once again, behind that trig word, we always put an angle, so I'm going to stick a theta on that. And so if we think about geometry, instead of opposite over hypotenuse like sine is, the reciprocal would be hypotenuse over opposite, I don't have room to write that down, so I'm only going to write down my trig definition. What would the trig definition be? It would be r over y, because cosecant is the reciprocal of sine. Okay? Whoop. Need to raise that up just a smidge. There we go. All right. For cosine, the reciprocal of that function is secant. S-E-C-A-N-T. The abbreviation for that is SEC. Okay? Behind the trig word always goes an angle, so we're going to put a theta. And since secant is the reciprocal of cosine, what would its definition be? Good, r over x. And then finally, whoops, let me move all these pieces down. And finally, for tangent, the reciprocal of that one, the name actually makes it easy to remember. It is cotangent. And the abbreviation for that is COT. We put our theta behind it. And what do you think the definition for cotangent is? X over y. Very good. So tangent and cotangent are pretty easy to remember. The other four students sometimes get confused. Sine goes with cosecant. A lot of people want to think that the sine should go with the secant because they're both s's, all right? Or that cosine should go with cosecant. That is not the case, all right? And here's what I need for you to remember. If you look at these words, 3 of them start with the prefix co, correct? Okay. And then 3 of them don't. They each have to pair up. If you have a plain word, you need a co-function with it, all right? Sine, it needs something that starts with a co, so it has to go with cosecant. Cosine, it's already got a co, right? It's already got the prefix co, so it's going to go with plain old secant. And then, like I said before, tangent and cotangent work out nice. Okay? So make sure that you can commit those to memory as well, because we are going to be working with our trig definitions so much that you really will know those. You will know those, I hope, better than you know your name. Okay? Questions so far? So the idea is to combine these two things together. To take our unit circle that we had before and somehow make that work with this. All right? So here's what's going to happen. I'm going to give you an ordered pair, and you are going to give me the 6 trig values. Okay? If I tell you that point P is -1/2, comma, √3 over 2, and I want you to find the 6 trig values, all I have to do is use that ordered pair and know my trig definitions and pick the right pieces and put them together. All right? When I do these problems where I'm finding the 6 trig values, I just go ahead and list them out. Sine theta, cosine theta, tangent theta, and then I make a second column with the reciprocals right across. Cosecant theta, secant theta, cotangent theta. I set these up the exact same way every time. All right? So tell me what the trig definition is of sine. Y over R. Okay? Does anybody recognize this ordered pair? It's on our unit circle. Ooh, that's important information to know. Because if it's on the unit circle, I know what the radius is. The radius is 1. Oh, this is going to make this so much nicer. Okay? I know that the definition for sine is y over r. But if I know that the r is already 1, really isn't it just y? Do you agree? Okay. So look at my ordered pair. What's my y? Root 3 over 2. Done. Okay. What about cosine? What's the definition of cosine? No, cosine is x over r, but once again, you know that the r is 1, right, because it's on the unit circle. One more time, I know it's on the unit circle because that ordered pair looks familiar, right? Okay. All right. So what's my x value? Negative 1/2. Done. Okay. Now what's tangent? It is y over x. Okay, so I'm going to have to do just a little bit of work to this. My y is the square root of 3 over 2. I have to put that over my x, which is negative 1/2. You can leave the negative out in front, or you can put it on top. That's where I leave it eventually once it's all done. Now what happens right here? If I have the square root of 3 over 2 all over 1/2, fraction divided by a fraction, you multiply by the reciprocal. What fabulous thing happens? The 2's cancel out. In fact, I can look at this right now, the way it's written, and if I have denominators that are exactly the same, they will go away. Only works in the case of denominators. With numerators, you have to kind of be careful. Okay? So this is just negative root 3. We okay with that? Yeah? All right. So cosecant, the definition of that is r over y. Ooh. Okay, so really that's like 1 over y. True? Okay. Another way to say that, if it's 1 over y is already a fraction, correct? Okay. If I'm going to take 1 over a fraction, I'm going to have to multiply by the reciprocal anyway. So my way of thinking, what I think is easiest, if I just take whatever the y value is and I flip it right from the start, make it 2 over root 3, and then I just fix it. What's wrong with this answer as it is? I've got a root 3 on the bottom. Can you guys just look at that and tell me what that would be after you rationalize it? 2 square root 3 over 3. All right? If you need to show the work of rationalizing it out to the side, you know, you're more than welcome to do that. Or if you just want to do it right here, just to kind of, you know, give you some peace of mind that you're doing it right, that's fine too. All right? Eventually, you will get to the point where you know these so well you won't have to do that. You may not believe me now, but trust me, you will do enough of these that it'll come natural to you. Secant theta, what is that definition? R over x, which if I'm on the unit circle is 1 over x. So instead of actually putting 1 divided by x, just take the x value and flip it. So what do I get when I flip negative 1/2? Negative 2. Done. All right. So far, so good? And cotangent theta? Same thing, right? It's x over y. You're just going to flip it. Okay? So it's going to be negative 1/2 over root 3 over 2. What happens to the 2's? They cancel out and go away. Now, on this one, I've got negative 1 over root 3. That is not okay. So you have to rationalize it, multiply top and bottom by root 3, and what do you get? Negative root 3 over 3. Very good. Okay? So if I know what the ordered pair is, I can calculate or figure all of my 6 trig functions. Okay? Question? Okay, the question is, can I just take, like for example, sine theta equals root 3 over 2. Can I just take that root 3 over 2 and then flip it for cosecant? Yes. Here's the catch. Eventually, you're not going to be asked for all 6 trig functions in the same problem. So you won't have that first column to fall back on. Do you see what I'm saying? Like, you won't have the previous answer to know to flip it. Eventually, we're going to get to the point where I don't even give you the ordered pair. All I'm going to tell you is which trig word and which angle, and you're going to have to sort through it, figure out what the ordered pair is, and then figure out if it's x, y, x over y, y over x. Okay? Let's do another one. Yes. In fact, let's try one where I give you the angle now. Let's get you some practice with that. What if I tell you this time that theta is 5 pi over 4? And then I tell you to find all 6 trig functions. Okay, so first of all, we have to know where 5 pi over 4 is. Is it in the first, second, third, or fourth quadrant? It's in the third quadrant, all right? Some of you are probably looking at your unit circles right now, and that's okay for today, but eventually we want to just know that 5 pi over 4 is a little more than a whole pi, right, which was on that negative x-axis, so we know it has to be shoved down into the third quadrant. If it's in the third quadrant, then it has to be an ordered pair that's negative, negative. Do you agree with that? Okay, and so then what's the ordered pair that goes with 5 pi over 4? Root 2 over 2, root 2 over 2. Very good. Okay. All right. So if that's my ordered pair, I can find my 6 trig words, correct? I want you right now, if you're watching this in third block, I need somebody to hit pause. I'm going to give you, or someone's going to give you 2 minutes to get the 6 trig functions. Okay. You should have taken a couple minutes to see if you can figure this out on your own. What's the definition of sine? Y over r, which we know that r really is 1. Okay, so my answer for sine theta would be negative root 2 over 2. Okay, what about cosine? What's the definition of cosine? X over r. We're on the unit circle, so r is 1. So what's my x? It's negative square root 2 over 2. Now what about tangent? What's the definition of tangent? It is y over x. So if I put my y over my x, I have the same fraction over itself. What do I get? 1. It's going to cancel to a 1. How many of you got 1? Raise your hand. Third block, I can't see you, but I'm hoping you're raising your hands. All right, cosecant. It's r over y, or 1 over y. So I think the shortest way to do that is take the y part of your ordered pair and just flip it. So that's going to be negative 2 over root 2. Can't leave it like that. What does it become? Okay. I'm hearing a couple different answers. I'm hearing the final answer and the step in between. Negative 2 root 2 over 2 would be an in-between answer. And we know from last chapter those cancel, so it's the negative square root of 2. That would be my final answer. If fractions reduce, I expect you to do so. Okay? It is not okay to not simplify those answers. Secant theta, it's going to be r over x, or 1 over x. And it's going to end up being the same answer, negative root 2. And then cotangent, it's x over y, which is 1. Okay, piece of cake, right? Maybe. Maybe. All right. So those are 2 examples of where you have to find, or is that 3? That was 3 examples of where you have to find all 6 trig values. Jason, question?
Will we ever have a value that's not on the circle?
Eventually, yes. The question was, will we ever have a value that's not on the circle? The answer to that is yes. And we call those points on terminal sides. And we will have those several times, but not today. Okay? There are several different, the question is, well, what information will we have given to us? And the answer to that is, it will come in different forms. I could tell you what the hypotenuse is. If I tell you the hypotenuse is anything other than 1, you're not on the unit circle, right? So things are going to change. If I give you an ordered pair that doesn't look familiar, like if I tell you that the ordered pair is, I don't know, 7, negative 12, That's not one that we're seeing on our unit circle, right? So as soon as you see that, you know you're not on the unit circle. So other things happen. Okay? And we'll get to that, but not today. What I want to try next, all right, and what you actually have as part of your homework assignment, I'm going to give you some angles, and I want you to figure out the ordered pair. Okay? They're not random angles. They're angles that have either no denominator or their denominators are 6, 4, 3, or 2. So somehow they're going to wind up on your unit circle. Okay? All right? What I want you to try to do between today and Monday is I want you to try to figure out if there is a way that you can remember which ordered pair goes with which angle. All right? Because if you can do that, then the rest of this is a piece of cake. So if I give you 2 pi over 3, without looking at your unit circle, I know you want to, can you think of or figure out what that unit or what that ordered pair would be? First of all, do you know where it's at? It's in the second quadrant. It's right up there. Okay? All right? That's where it's at. So you already know that for the ordered pair, what are the signs of that ordered pair? Negative, positive. Good. So now you just have to know the numbers that go in there. Every time you have an angle that's over a 3, what is it? Is it the 1/2 root 3 over 2, or is it the root 3 over 2 1/2? It's a half and then a root 3 over 2. Good. Good. That's it. That's what you got to do. All right? Any angle that is over 3 is going to start with a 1/2. It's going to be 1/2 comma root 3 over 2. If I give you 7 pi over 6, where's that at? It's in the third quadrant, right? Okay, if it's in the third quadrant, then you automatically know that it's negative, negative. All right? Now, what's the ordered pair that goes with it? It's going to be reverse of what we just had, right? It's going to be root 3 over 2 and 1/2. Okay? Some of you are looking at your unit circle, and that's fine. Okay? But eventually we want to be able to do this without it. We just want to know it. Okay? What if I give you 3 pi over 4? Okay? Where is that? Good. It's in the second quadrant. All right? So that means it's going to be what? Negative, positive. And then what? It is. It's square root 2 over 2, square root 2 over 2. You know, I always think that one's easy to remember. Do you know how I remember it? 2 plus 2 gives me 4. That's how I remember it.
So anything over 4?
Anything, that's right, any angle that ends up being over 4 is going to be root 2 over 2, root 2 over 2. The signs are going to change. So, ooh, here's a good one. This is a fabulous one. What if I give you 15 pi over 4? Ah! Big angle. Big angle. But that's okay. It's the same as what? Are you sure?
Okay, well,
Where's it at? Is it in the second quadrant? In the first quadrant?
that's 7 revolutions. 4 quadrants, because then 16 will be a full one. So it'd be 7 revolutions in the 4th. Because
I agree that it's going to be in the fourth. Okay. What is 15? Okay, now careful, careful, pay attention. What is 15 divided by 4? What is that? Well, it's almost 4. That's a good way to look at it, Lydia. Lydia says it's almost 4, right? If it were 16 pi over 4, wouldn't that be 4 pi? Now, where's 4 pi at? It's all the way around once, all the way around a second time. Oh, but wait, it's not quite, right? So reverse. What quadrant are you in? Third block. You couldn't see that fabulous demonstration, but we reversed our angle. There's 1, there's 2, and then it stops right there. Right? It is. It's almost 4 pi, so it's almost 2 times around, right? Now remember, keep in mind, 1 revolution is 2 pi. Don't confuse your pi's and your revolutions, okay? So what is that? Even though that's a super huge angle, it's still going to be root 2 over 2, root 2 over 2, but what are the signs? Positive, negative, okay? That's the idea. All right. What I'm going to do now is I'm going to stop and I'm going to give you your assignment. It is modified from what is written on your sheet, okay? So, well, there are 2 worksheets and a little bit out of the book, okay? The first worksheet is just a quick review over fractions. We've already reviewed pretty much everything on here except for the bottom. I threw in some conjugates to see how you handle those. But I think you'll be okay. If not, see me Monday morning. The second worksheet, it's where you are finding the coordinates on the point of the unit circle. So in other words, kind of like what we just did. I'm giving you an angle. You have to give me the ordered pair. And then out of the book, I can't, actually, let's do this. Since it's Friday, we'll just give you the 2 worksheets, and we'll pick up on Monday with the bookwork. How about that? All right? Happy Friday. First block, learned a lot. Third block, I hope you did too. Have a great day.